1, 2, 3. Yeah, let's get started. So please take your seats and we can start talking about different cool things. Yes, yeah. Awesome, thank you. It was really quick. Usually it takes a lot more time to actually gather people together. So nice to see you all. Welcome to Altenar. Welcome to Malta Tech Talks. My name is Nikolay Markov. I work as a data platform lead here in Altenar. And I will be your host for this evening. And so just for starters, how many of you guys are here for the first time? Quite a lot. Okay. So just a bit of information. We basically have two rooms. So this one is where all the, like half the magic happens, where we discuss, we have talks, we have discussions, we have a lot of interesting things. And in another one, which is across the hall, there is some food, some water, and some place to also, discuss everything that we want to discuss. Because one of the ideas, one of the things that we have in mind is not just, to have like people just present and then everybody goes home. Ideally, we want to spark some conversations, to have some interesting discussions, and yeah, if that happens, it would be awesome. We also have like two bathrooms, one here, one at that side. Feel yourself at home, and welcome once again. All right, so
Thank you, Nikolay. Do you hear me well, guys? No? Okay. Let's use this. Is it better? Thank you. I will talk about databases, but at first I would like to tell you that I'm here not because of my English, and please apologize it. And I'm here because of a sort of love to some crazy things as a database. I hope someone here is the same as I am. I will talk about a contention in the databases. A little bit about my experience. I'm working in IT technologies more than 20 years. I begin as a software developer, as a team leader, and after that I focus my experience and my job on the databases area. And more than 8 years, I'm working with a high load on-call engineering on the third level support, which is support of urgent cases of the loading when you should resolve as a high-skilled engineer something pretty fast because we are working as a sports book, as you know. So, a little bit about Altenar. It's an international company with different clients all over the world and in a different time zones. Because it's a different time zones, we haven't an option to make some changes or maintenances or transfer data from some area to another for long. Actually, we have only 2 minutes of downtime every 2 weeks by the previous consideration with the business level 2 days before. So if something goes slow in production right now, it is a downtime for us. If it happens at the night, at the early morning, at the middle, it's the same. So you know how it works. The company is growing and pretty fast, and loading is growing as well. Our traffic, time to time, duplicated or triplicated during the year. And time to time is a little bit unpredictable, especially for the end-level engineers, not for the leaders of the company, I hope. So, it will be at first a story about some November, December period, little bit before Christmas. Everyone should be happy, but in the sports book there is a championship league. Championship league is the most popular betting point of the football championship. I know nothing about football, but I know that it's a very hot period. And in November, I and my colleagues beginning to face small peak level in Grafana, small signs that something goes wrong, but not significant. No one from the business level have seen it, but feeling should talk that something could be wrong. And as you know, if it's avalanche or snowflake, it can grow really rapidly. And it happened. At first, we face a 1 minute downtime. It's not significant, it's just a small downtime. But we don't know why. Everything goes smooth. But at the some level of bit rate, we face a rapid degradation. And after that, again, everything is fine. So it's strange. We improve our monitoring because we used all existing tools to analyze it. It doesn't happen. What we have done, we added weighting statistics on the database level. Also, we added a log, extended log in the code level and so on, but I am talking about the databases. And we face, just a second, yeah, we face that is related with some waiting time type which calls in MS SQL Server, page large. Page large exclusive. Okay, something new, we never face it a lot, but now we understand what it is, but still don't know why it happens. And we start reading, talking, Googling, analyzing, talking with artificial intelligence, and try to understand what's happening. And what we found? We found that it's a known issue, and some people and companies faced it the same. It's related with a page large, as it is in the name, but related with a lock in memory to prove that data are accurate for one moment. Most cases when it happens, when you assign new identifier, if you have growing identities in your table, 1, 2, 3, 4, and you should be sure that new insert will have +1. Database should be sure, should rely on it. There is some databases that are not using the same approach. They are using a different, and I will say about it a little bit later. And SQL Server make this. And if you have threads or parallel processes, it will be a contention before one process will be allowed to make this log to be assigned a new identifiers. It's a theory. It works the same. But if you have a lot of processes, all of them try to insert in the last page. And it is a last page contention. It's like a bus, last opening door to check in, and everyone tries to input. And if everyone tries to input into this bus, they stacked, and bus can go without anyone. So it's a graph that describes exactly that I said before. So instead of increasing of the insert rate, you face a degradation of it, and latches are increasing. So it is what it is. And we face this situation. Sequential increasing key have been a part of the architecture. After that, we face a lot of traffic and a lot of insert operations. We face a last page contention. It becomes critical. And after the some critical level, weightings were more than inserts. And it happens. Contention should be somehow calculated by the core of the server. I mean, you have a lot of processes which wait their own queue, and they take a CPU, they take memory, and they doesn't allow business to do what it wants. And final end users are waiting for something like a create order, place bet, log in to some site, and they can't. And in 13th November, we face this downtime. We almost be ready, but not enough. It was about 20 minutes of significant degradation of the insert rate. It was related with a lot of waiting processes, which is on second, third, and fourth graphs. And it shows us that per second, sorry, it's not minute, per second, we can place only 300 bets. That's not enough for business. We should do something. We write a postmortem. We explain it to our leads, to our business level, and starting hurry up because it was a quarter final, and in 2 weeks we were waiting for final matches, and loading should be increased more and more, and downtime will not be acceptable by our clients. So we found resources which are related with this contention, and we found how it works in the numbers. It was related with a 2,000 insert operation in some table. And it's a structure. You can never mind about it, but you should know that some tables have a smaller contention than other tables. Of course, because you have a relational database, and some tables are like a description or order items, and some of them are general items, which are pretty low insert rate. So we have 10 days. What we can do? We can find methods which can improve us faster. But what method we should choose? Which can be more effective, or what type of method you can rely? You should test it. And actually, you can't test it in general in all systems, because you don't know where is another degradation. Probably some part of system or even test environment will not be suitable for your test case, and you can't rely on it. So the best approach, and take it like advice, is testing on level of your responsibility. So we tested just a database level at first and found that in our case, the best method is number 6. It's partitioning. Actually, it depends of type of data, of type of structure which are you using. Some methods are not applicable, like a 7 used in memory tables. Actually, we have a table which was about 4 terabytes. 4 terabytes memory will have different contentions that are not described in this presentation. Just to stop here a little bit. Another methods can work, but some of them are related with the significant changes in a core architecture. For example, if you would like to change identifier type, you should change visualization of such identifier type. You should include a business identifier, which will be almost the same as the previous identifiers that you use, and so on and so on. 10 days, it's unreal. But partitioning worked somehow. But will it work with the old system? I mean, you have a lot of queries which are not related with the insert operations. You should update data, you should find it, you should analyze it, probably prepare some operational reports, how to do it, how to check it. So you should implement whole system tests. You should have a lot of meetings with the developers team. You should change some queries. You should optimize indexes for the new structure. And also, if you are using a partitioning, who knows what is a partitioning here? Just to, better. Okay, let me a little bit explain here because not everyone is familiar with it. If you divide one physical table in a different, one logical table in a different physical separated smaller tables, and this table will contain some key, for example, number 1, number 2, number 3, or data today, tomorrow, and yesterday, or probably year, or anything else, and every partition will have own index structure, or every partition will have own probably location, or it can be managed itself. It can make you happy and your system more happy. But also it will be related with the following. If you try to find something and you don't know which partition should contain it, for example, you have a partitions related with day. When Nikolay ordered something, for example, pizza, I should scan all partition, and it will be physical switching from one partition to another, and this type of search will be slower. So all requests, all important requests, should be checked and optimized for the new physical structure. 10 days, guys. Actually, it's a crazy idea. I don't advise to repeat it. And we were fine on the tests. And we had only 2 days in this case to go to production. Because in 12 December evening was a first important game with a high traffic. How to deploy it in production? Test, deploy. Oops, we have a terabytes of data. You should convert it. We should migrate one schema to another. And we did it. Finally, tables we all divided into 24 partitions. It's related with the number of CPU cores, because every core can take care of its own partition and calculate and take its own queue and so on, so it's reasonable. We checked and changed our queries, we changed our code, we prepare migration, And we started. Here I would like to take a little bit attention to all teams which were involved here. All developers, all testers, everyone helped to make it real, and especially Yaroslav Frolov. We had only one weekend during the November-December because of this migration, which have been done. It's a 3 phases process to reduce downtime to 1 or 2 minutes, as it is expected by the business level, as I said in the beginning. You can create a parallel new structure which will contain all data at the end. How it's possible? At first, new data can be synchronized by triggers. Who used triggers before? Who is satisfied with it? Okay, you know why. For everyone else, triggers are related with loading degradation too, because you should proceed something before operation will be finally over. Also, triggers are really difficult to stop. If you have a contention and triggers are related with the loading, you can stop triggers online. So if triggers make you pain, you can't avoid it. Also, if you have triggers, you should be 100% sure about logic that is covered on date. So it's carried, but for 1.5 days, it's possible. And we use it to synchronize new records. Other records slowly cooperate during the same period of time. And it's the final of this operation. We have a synchronized data, but it's a little bit different in our case because we archived old records at the same process. Kill as many targets as you can. We did it too. And this time, we open our laptops, open Grafana, open logs, open everything, and we're waiting when our final clients will make this loading and probably more. Sorry, something happens. Yeah, thank you. So it's a 3 days game. One is bigger than another. Thank you. And we found that improvement was really significant. We started with 2,000 records in a contented table and increased up to more than 20,000 operations per second as well. We investigated the problem, we solved this problem, we tested it, we reduced our operational database, archive something, and we managed to do it in time. We increase final limit of the system, I mean, not in contention in one table, but business level improvement is 10 times from the initial level. Archive something, optimize some queries, and face loading, happy and tired. Happy Christmas. So, little bit about contention. But before I continue, have you any questions, guys, about that part of presentation? The site, yeah. Thank you.
It's very interesting what you're talking about. One thing I found interesting is like you got did you not have load tests done before to know that your peaks can sustain much more than 300 transactions per second? Because it seems like it came as a surprise by the way you were explaining it, where you started seeing that glitch happening with the pages. Should that not come out in testing before?
Actually, no, because load tests were 50% more than average traffic. And we never try to test it in a stress way. So load test, it's not the same as stress test. Now I try to use a stress test at first, and after that go to the load test because it's more important and you know where is the level of degradation. But at that stage, it was like it was, yes. Sure.
Yeah, any more questions right now? No, we'll have also time. Oh.
Mine is super simple though. Oh, the partitions were all on a physical machine, not distributed, because you mentioned cores, so all on one physical machine.
Yes, in our case, if you are talking about MS SQL and actually just a small pending, we use a standard edition. It's not available to scale it with different machines. So it's a restriction in this case.
And so this is basically, I was going to ask, but I think it's not applicable here. These are just multiple writes bets in the sense you're not going to run into problems like a hot partition, you're partitioning with a modulo 24, so it's equally distributed. You're never going to have, in load balancing terms, all requests going to one shard because you're reading from one particular partition.
Sure, it can happen, but it's like a randomize. I mean, these partitions are sorted. Let me little bit switch another slide. Yeah. This one. It's related with this operation, bet identifier percentage 24. Just a second, I will try to show to people who are in room.
It's a modular, right? Like
yeah, it's modular operate, and you will not have a contention of the select operation related with partitions because it's not a date. It's not a hottest date and so on. So your first identifier is there and second there. But if you would like to group, for example, last hour records, you will face some degradation. But if you are using a good indexing that I mentioned already, we should improve. It will be acceptable. But some degradation in this case is possible and should be carefully managed somehow. Yep.
No, it's super interesting. Thank you.
So, you will have a time to make more questions according to this part, but I would like to switch to other databases because I know that not everyone here has been using MS SQL. And other databases, dependently of the core of the machine, work with last page contention and produce it different ways. But in general, it is what it is. It is a contention related with something in memory, not on the disk, which should be available for everyone, but should be trustly available. So if you should log something for sure that records are correct, it will be contention on this point. So, and it's every time 3 steps. At first step, you face, hold on, wait for a second or for a microsecond when I finish. After that, a lot of waitings, queue, contention. And after that, side effects, which are really significant. You can see it at first. It's a CPU level, memory pressure, a lot of connections, something goes wrong. And at that moment, you don't know what happens. there are a lot of different databases, more than the screen. And some of them work the same way as MS SQL. For example, Oracle. The same trusted, memory-oriented, latches-oriented type of working with the last pages, and it's different name. Buffer, busy, wait. That's it. The same. Works the same. Last page, inserts, the same problem. If we will look at the MySQL, it's different. Why? Because they insert without such trust level as it is in Oracle and MS SQL. They insert just in memory, but update operations are really a problem here, because to update, you should lock a row, and if you have two updates in the same time at the same range, you should lock the queue to lock row. If you have a dozen of such updates, you should lock and lock all queue. And as soon as first operation will be proceeded, another one will go at the step forward, but 100 operations in the queue will try to be the first. They haven't another one queuing. And because of it, it's contention on update. The same contention on update has a PostgreSQL, because it works not the same way as MS SQL with the memory areas, but the same approach for locking tables and locking rows for operations. Yeah, it's some table. Probably you will have a look at this after in the presentation, just to structurize these contentions. And also I included into the presentation some hyperlinks to check this subject deeper if you are interested. So, thank you. And do you have questions?
Thank you. Just something to remind you guys who are actually watching this on YouTube, can ask questions and we will receive them and maybe even answer them. So this kind of reminds me of these conversations we had with students about distributed systems, right? Where if you read like on some marketing material that some system is linearly scalable, that's usually a very huge lie, because there is a contention component. It's almost inevitable in most of these systems. And the interesting part is that it doesn't really depend on which level we're talking about. It may be a distributed system on like thousands of servers, or it may be a system in one machine just running on like multiple cores. It's still the same thing. So, the question we have from online is: could you please reveal what the version of SQL Server are you talking about?
It was a 2019 version, and after that we also already migrate to a 2022. So this approach have been tested on 2019, and now it successfully works on 2022. It's almost the last one. I mean, yeah.
Amazing. Thank you. And that one more question from the same person. I have no idea what it is. Did you check your TempDB setup and did it influence something?
Yes, we had a TempDB issue previously, and it was already good monitored, and we have already 24 files for the TempDB, and yes, it's another one good story. I can talk a lot about it, yeah. Okay,
perfect. So then sure, we can discuss it afterwards, but if you guys have any questions right now, yeah, we can try and answer. Okay, I see one hand there.
I'm not sure if it would have an effect, but was there any replicas involved? And if you have replicas where they sync or async?
We have a sync replica. It's an availability group. It calls availability group. But for standard edition, it's not readable. But it's another one type of known issue when you are waiting for the synchronization of the records. But it will be related with a different type of wait. So because of it, just let me show, sorry. Who is boring. This is good. If we analyze waiting statistics, there are a lot of waiting types, and every waiting type is related with its own process in the core of the database engine. And in this particular case, it's something in memory like a contention because it's a page large. If you will see page I/O large, for example, it will be related with the time of the loading from the disk to the memory. If you will see type related with the availability group synchronization, it will be the same as you talk about. But switching to the asynchronous mode is really dangerous because you can lose something, but it's not a worst case. If you will face the disease, like 100% downtime and so on, it will not be switched automatically to another node. And you will face downtime before the engineer log into this machine, load it, switch it manually, and wait, it will be available. And you already lost something. So it's, yeah, it's a terrible thing. Because of it, you should use not only a good network, but also good disks, because it duplicates a disk operation, right on one disk and right on another. Thank you, good question.
Okay, thanks.
Any more questions? I had one from online also. Someone's asking, did you use file groups when enabling partitioning? I have no idea what it means, but...
No, we didn't at first, yeah. And what it means that you can place on a different physical disk some of your files. For example, 24 files, 24 different disks. Every disk has own controller, and actually it will be a little bit speed up, but because of our architecture, it's not available. So for us, it's a restriction. For you, it is possible option to improve it a little bit more.
Thank you.
So I think it's a really difficult subject and really, I don't know, thing that you should face or not face. And
well, let's just ask, like, how many of you guys actually worked with SQL Server on, like, trying to maintain it and support? Not many. Okay, there are some people. Okay. So, but I guess that one of the points is that it has there are similar cases in other databases as well, right? Different points of contention, I guess, and in different places.
I mean, if you are doing anything with a system, you will face contention on some level of loading. It's physics. You can't divide one to infinity in a real world. It's only math. In real world, you will have a smallest piece that is available for you, and after that, it's collapsed.
Okay. Any more questions, guys? See any? So let's say if not SQL Server, then what? Like Postgres? Okay, some for Postgres. MySQL? MongoDB?
Wow.
Okay. But, I mean, quite a diverse group we have here. Anyway, so I think you'll still be able to catch Irina we will have 10-minute break now. So if you're still here, you can maybe answer some more questions. And yeah, let's make a short break and we'll return in about 10 minutes.
Thank you.
Thanks again. Right. So let's continue step by step. I know I told you guys that it's amazing that we're having so many discussions. But we have some other interesting topics, other interesting presentations today. So yeah, take your seats. Fasten your seatbelts. Make sure you see the signs, no smoking signs are on and on off, whatever. So today, I think we're talking about the things that are considered by most, the kind of technical pinnacles, technical achievements of humanity, right? In terms of IT, like if you think of stuff like operating systems, like web browsers, right? So probably databases are also one of the things which is around there somewhere. And another thing that comes to mind is compilers and low-level architectures. This is also like an amazing topic going, if we go into details, like every single system boils down to that. And I'm really glad to invite Mikhail Gusarov from Blackbird to tell us a bit more about compilers, about how we throw away our resources on different kinds of inefficiencies, and yeah, say hi to Mikhail.
Thank you, Nikolay. I would like to talk about performance today, and I would like to step back from the database operating systems and get back to the basics, to our hardware, how we actually run our programs. By the end of the talk, I hope you will agree to all of this, to all of these three things, that CPUs are much faster than you think. Even if you think they are fast, they're still much faster. That is still important, and if you're a software engineer, you can use this knowledge. So, does anyone recognize this person? No, it's not a very well-known person in IT. It's Peter Drucker, one of the founders of the management, modern management, and he said, "What gets measured gets improved." What I would like to say is that we don't measure our CPUs. We know a lot about our hardware. We know a lot about the networks, how fast it is, what's the throughput, how big our storage or RAM, how fast it is. But when we go to CPUs, all we know is clock rate. What does that mean? How much data can we process with this clock rate? Is it even a constant? So let's figure it out. To start, we'll just get some thing you usually do when you do some low-level networking. You get a checksum. It doesn't matter what checksum it is. I just invented one. So if you look at it, you need to process a bunch of bytes. For every byte, you need to do 6 operations. Just plus or shift or XOR, the most basic ones you could do on the CPU. So let's try to implement it in different ways and see how much performance can we get out of it. Let's start with everyone's favorite, Python. It's a straightforward implementation of the checksum. It does exactly the same as a formula did. So let's just run it and see how it goes. Well, apparently it doesn't go pretty fast. That's 1 gigabyte of data. It's still running. Let's speed it up a bit, because otherwise we would be here until tomorrow. Yeah, it's still running. So it's a Python. It's 1 gigabyte of data. Really? Are our CPUs so slow? Yeah, it's 2 minutes. Okay, it's 2 minutes more. But how fast it is? Do we have any benchmark? Do we know, is it a 10% of our CPU maximum performance, or it's a 0.01? We have no idea because we don't have any measurement. Let's go to Go and just implement the same thing and see how it goes. It's the same algorithm. You could run it. You could run some benchmarks and see how it goes. Now it is 136 milliseconds. That's a 200 increase. And we still have no idea how fast it is. We still have no way to measure it. We don't even know, is it close to 100 or is it close to 1%? Well, maybe we should just go to the metal and use C, everyone's favorite, right? If you do it in C, most likely it will be 100% performance, right? The same algorithm. Well, the only thing we did is we changed some syntax. We run it, and we get 10% increase. That means we are getting close, right? If it's a 10% increase, it's a C. We're probably getting most of it, right? Not really. We could go and find out some manuals from Apple, very obscure ones, and start reading them. These numbers, most of them are from the optimization guide by Apple, and I'm sure not everyone read it. We could look at it and find some things like ACMD execution units. You could find the width of this CMD. You could find the timings. And after we spent a couple of hours trying to understand what it means, you could find out that our core should be able to do that much bytes per second, just operations. And how does it compare with what we got? Well, apparently our best C implementation was just 5% of our maximum performance. And that implementation, that algorithm was chosen to be using all of our CPUs. I specifically constructed that hash function so that it won't have any, that memory won't have any impact on it. You will have enough bandwidth to get data from memory to the CPU. So we are still getting only under 5% performance. What's going on? One thing that's going on is that our languages are really outdated. They were created in 1980s. They weren't updated since. Whenever you have a new language, it's just a rehashing of old ideas. And that means they don't get to using new features our hardware engineers have been so busy working on. That is what you get if you want to get at least some performance out of your programming languages. First of all, you see, the syntax becomes awful. You can't really read it. You have to basically put it into LLM and try to ask it to explain what it means. It's the same algorithm. It's the same algorithm, but it uses the hardware that was in our CPUs for 25 years. When you use a regular C, you operate on 1 byte at a time. But our CPUs, for a quarter of a century, had a hardware that allows you to operate on several bytes at a time, and that is not in C, that is not in Go, that is not in Python anywhere. The only way to get it is to use some library or to use some compiler extensions. And it means whenever you want to have some performance, you really have to think about it. You don't get it automatically. Now let's run this one and see how it goes. It's a benchmark, don't worry. So it gives us much better performance. You get another 17 times increase. And this is already close to our measured, calculated CPU. But why it's still not 100%? We're still missing something. Now it's programming education. Our universities mostly don't talk about performance. They don't talk about hardware. They say, okay, there's an algorithm, there's big O notation, and do whatever you want with it. They don't talk about instruction level parallelism. They don't talk about multiple execution units. To do that, you have to go and look it up yourself. And what you get when you do everything, you get this mess. Your languages are awful, and you don't have any support from your compiler. You just do it this way. You run it, and you get a little more than you thought. So this mess actually gives you the whole CPU, all it can do. But why it's 112%? Maybe the whole calculation was wrong. Maybe you're just measuring something wrong. Actually, there's an answer. It's in this slide. Could anyone spot it? Sorry? That's right, sustained. They were doing the benchmarks on a maximum clock rate. That's right. So, we were doing benchmarks on one core. Now let's think about what it means for the performance. We've got 10 cores here. We could do the same calculations we had before, and we're getting this number at the bottom. We could process 2 terabytes of data on our CPU per second. Think about it, 2 terabytes of data. When you boot your operating system, how much data does it process? I'm sure it's not in terabytes. So, I guess I made my point about that our CPUs are faster than you think. Now let's talk about why it's very important. First of all, you could accidentally turn your modern MacBook into some iBook from 1999, and you won't even know about it. Just use a wrong language or use your wrong algorithm, and you're getting 5,400 decrease in performance. Or you could accidentally introduce a very serious performance regressions and don't see it. Our CPUs are so fast that when you're developing and testing, you might just not see it. Here's it's a graph from a recent blog post by a proxy company, and they were measuring SSL stacks. SSL is very CPU intensive. Whenever you have a CPU, even whenever you establish a SSL connection, it's CPU intensive. And they found out that OpenSSL project, when they released OpenSSL 3, they introduced 1,000 performance regression. They got 1,000 less, fewer connections than they could do in OpenSSL 1. And nobody noticed until Haproxy tried to get more of their hardware they wanted. So they had to go back and fix that. What else would happen? If your CPUs are so fast, you may accidentally introduce quadratic algorithms and have pass your development, your testing, and you get it to the production. And when it's production, at some point you get a slowdown. This is from another blog post. A person cut down GTA Online loading times because he found out that GTA Online had an accidental quadratic algorithm. Nobody actually tried to make it quadratic. It was just a programming error, and it was found only when GTA Online increased the amount of ads they show, because the ads were loading, and that load was quadratic. What else might happen? If your CPUs are so fast, at some point you don't even need distributed algorithms. This is it's a blog post from 10 years ago. A person tried to get some distributed algorithms, find out how they perform, and then implement the same thing in Java and run it on a local machine, single-threaded. The result was, whatever he tried, whatever distributed systems he tried, single-threaded performance was better than any of them. And it was 10 years ago when our CPUs were much slower. Now you probably can get much bigger data sets processed on the single machine better than on multiple distributed ones. What else you could do? At some point you can throw out your Hadoop cluster, because you put something on Hadoop cluster and then you replace it with a shell pipeline, you increase performance to 100 times, because you didn't know your CPU was so fast. So this is important. We introduce performance regressions. We misuse our CPUs. We introduce complexity when we don't need it, just because we don't know what our hardware can do. Now, how can you use it? First of all, if you know your CPUs are fast, you could start applying it directly. There are tons of libraries out there, if you know where to look for, that are designed to be performant, that use recent CPU instructions. And the people who did it, they did read about SMD, ILS, and whatnot, and applied it and suffered, so we can all use it. What else? If you know the speed of our machines, you could have a baseline, and that's a very important thing. If you know how much time you need to process some amount of data, now you have a measurement. You know how much your implementation is far from it. And that means you won't accept a 1,000 decrease in performance just because you didn't think about it. Because you know it's not seconds, it's milliseconds. And if there's a second, it means something is really wrong. Here's a case study. It's from a company I worked for a couple of years ago. We had a database schema upgrade slowness. It was a homegrown database, don't ask why, but it was linear. It was pushing an hour in production to just upgrade. And what happens when you ask engineers who don't know about performance what to do with this? They start inventing some smart solutions. Split the database, or make it run concurrent, or make the schema upgrades run concurrently, and whatnot. And then you just go and look, and you see the database is several gigabytes in size. It shouldn't take 1 hour to do that. You go look at it, you see if the database is configured properly, you see if the database operations are done in a right way, and you go back to the engineers and say, here's a bottleneck, go and fix it. So instead of spending months on splitting our database, we just spent a couple of hours. Another one, please raise your hand if you had to implement database mocks in your code, just for unit testing. Right. Did anyone enjoy it? Just to introduce an interface somewhere in your code, just to be able to mock out your database. You don't have to. When it was invented, databases were big beasts. They were on separate machines, and you couldn't just use it for your unit testing. But now, get a process. It is still from 1980s. It runs in 100 milliseconds. You load the schema, you load the unit testing database, and you run it against Postgres like in production. You don't need interfaces. You get high fidelity tests. What else? You could do and implement your whole system on a single machine because your machine is fast. You could get a very fast machines even from the cloud. Or Nikolay could tell you more about single machine databases. Yes. So you could just throw away all your tools for distributed systems. Go and install your single binary on a single machine, run a database, and that's all. You just decrease the complexity of your system 100 times. What else? You could just run your whole system on a laptop for developer. You don't need to create a Kubernetes cluster and deploy a lot of stuff on it. Just run it locally. Your machine is fast. You run everything. This is a screenshot of a tool I'm using for the second company in a row. It just runs a whole system in a TMUX. You probably know it. A bunch of processes. You start it, you stop it. It's under a second, and you get the high fidelity implementation installation. So, I guess I showed you. You can use this knowledge. Now, any questions?
Thank you. One, two, three. Doesn't work. No. We still need something working. Yeah. I think, David, you may vibe with this talk, right? So, this reminded me of that joke. You guys remember that game we used to play called Angry Birds, right? When it was released, there were a lot of jokes about that like now it's about 60 years ago, actually. The performance of all the computers they had at NASA was similar to the performance of an average smartphone in the time when Angry Birds was released. So NASA was kind of launching spaceships into space, and we were launching birds or pigs. So, yeah. I have a question. So, do you think it kind of still makes sense to, I don't know, to switch to Gentoo and just compile everything for the architecture that you want to run it on?
For the microarchitecture, some of the inner loops maybe. It depends on what you're doing, but mostly no. It's like when you use the knowledge of the CPUs, you get an order of magnitude improvements. Whatever you get from the smallest microarchitectural things is just a %.
Yeah, this one works now. Okay, it's random. You have to guess which one works. And I'm mostly thinking in terms of Python because I mostly use Python for a lot of projects recently. And I think, I remember those times where you actually had to, if you use, let's say, NumPy or Pandas, it kind of made sense to compile it on your machine, especially if you had specific, BLAS libraries installed, so to optimize, to vectorize the computation. And there was even some competition between like open versions like OpenBLAS and say Mikhail, which was like an Intel math kernel library for scientific computations. Does it make sense to go into those details now? What do you think? Or
I would say ask someone else to do that. And I'm not even joking. 25 years ago, we had incredibly diverse operating systems, hardware. Now we are coagulated down to x86 and ARM and a couple of operating systems. So now it doesn't make any sense to repeat that work. Most likely, you could get a good distribution that did it for you.
And what do you think of LLVM, for example, as like an intermediate layer? Because you said that now there are no systems or just a few systems that can actually try and vectorize your computation for you. I know I read that in LLVM at least they try to do something like that. So when compilers that are using an LLVM, sometimes they can get vectorized computation there.
Yes, they do. So I had to actually cheat a little bit in the PC and find an implementation that doesn't get vectorized automatically. Because if it does, you get some performance out of it, yes. It might not be the optimal one you could get from the manual work, but you get another order of performance, yes. So if LLVM works, if GCC auto-vectorization works, it helps.
So, and it's the same with JIT compilers, right?
That's right.
Yeah. Thank you. So, any questions? Yep.
When you say if they work, can we help as a developer? Can you help them like, listen, dude, vectorize this?
I didn't do much work on that. Whenever I saw it, it's usually a form of the algorithm. So this auto-vectorization is pretty simple. It's just a pattern matching. So if your algorithm is fitting the pattern LLVM or GCC developers put in, it will work. Otherwise, you either better doing it manually or restructuring your algorithm to match it. And it's not very useful because, well, you have to guess what they did or go and read the source code.
Yeah. Fair enough.
I wonder if it makes sense now to also start looking more towards GPUs. I know that, I mean, several years back there was a whole, hysteria around that, and people were saying, okay, let's just all switch to GPUs because they vectorize everything a lot faster because GPUs were made for it. So I think now it's a bit calmed down, and I know that there are several layers of dark magic that you have to know to actually code for GPUs. But would you say it's something that can also be considered here, like if we run this same code, for example, not on CPU but on GPU, on a MacBook or on, I don't know, on GeForce, would we get more?
Definitely, if your algorithm is amenable to it. Because the CPU cores, GPU cores are much simpler. So if your algorithm doesn't fit, it's not going to work very well. On the other hand, remember the GPU came from the games, and game developers are very good at performance. So GPU languages are already very good at this one. You don't have this problem. CPUs are older. CPUs are from 1980s, at least the current generations, and so it's a problem endemic to CPUs. We are stuck in this past, not like GPUs. GPUs are much better. Yes.
And what about like M2, the new ARMs, these kinds of things?
They are the same ARM, and Apple didn't invent their own languages to go with them. M2s and ARMs, made by Apple, they actually made it a little bit easier for us developers because they finally implemented a way to speed up transfer of linked list. Really? Linked lists, you probably know about them, are one of the worst data structures for the CPUs. Finally, ARM M1 can walk it fast.
Thank you. Any more questions, guys? Yeah, come and participate in discussion.
So I see your competition table about different language, but how about Rust? So the people now, they say that's promising to using Rust because, promising to using Rust. Rust now has a better performance, even with a Python, and because they have a zero abstraction level or trust level, so this is make it faster. Even I working as a front-end developer, and someone come to me and say, okay, by the way, the interpreter that's using with React is very bad, but when we converted based on trust, is faster 33%. So how about that? Yeah. So tell me what is your recommendation of?
Right. So on Rust, first of all, it's the same 1980s language. It doesn't embrace SMD, instructional parallelism, and whatnot. It goes to LLVM, so it gets all the benefits of LLVM optimization, and it will get all the accidental auto-vectorization if it works. But otherwise, it's not much better than C. You get approximately the same. you might get a little bit better code from the compiler, because Rust compiler might be able to omit some checks or something, but otherwise it's the same. If you have to have the most performance of your cores, you will have to go down into assembly level. For front end, yes, anything that can replace JavaScript is improvement. No, really.
I drink to that, yeah. Yes, also, I don't know if you've seen that there was a piece of news where there is this decoder, I think it's video decoder, AV1, right, that was written in C initially, and there was a group of enthusiasts who actually rewrote it in Rust, and it is about like 5% slower than C implementation. And they spent quite some time trying to optimize that, and now they started a bounty. So they are asking people, so whoever can still using Rust, fix it so it's at least on par with C version, they are going to pay 20,000, I think, 30,000 bucks or something. So, yeah.
So when you go to compiled languages like C, Rust, or even Go, it's all in percentages. You could get 20% up or down, but it's not about orders of magnitude improvement.
Any more questions? Anything else? Yep.
Thanks for the talk, very interesting. One of the things that I find this type of problem very frustrating as well in different parts of the business, but do you have any experience in any system which, like, for example, when you do npm install, sometimes it compiles everything with, that is aware of, for example, using graph isometry and stuff like that, is aware of standard algorithms, and as it is compiling, takes into consideration your hardware, because, like, as you said, we have 4 types of hardware basically: RISC-V, ARM, you know, x86, 64 basically, and maybe somewhere Spark in some bank, somewhere like that. Do you know of a system that's actually good at, like, there was a case where Sun Microsystems, which I used to work for at some point, they had their Java system used to basically compile, run on a VM, which is basically directly related to Spark, so it was more fast than C because, you know, the language would compile directly for the processor you're running. It was very streamlined, but when you port it to x86, it was very slow. Mm-hmm. I'm asking you, do you have any experience of any cross-compilers that actually do the magic for you to achieve this with any language, basically, because then it becomes intermediate, right?
Unfortunately, no. I don't know anything that is automatic. The only time I saw this working is that when you provide manually provide implementations for the architectures. Otherwise, it just doesn't work. On the other hand, you don't have to provide 25 implementations now. You're now down to 2, and it helps. Okay, 3, yes.
Oh, maybe we can feed it to ChatGPT, and then. Yeah.
Actually, ChatGPT is pretty good at describing what SMD instructions do. Not sure why.
I'm just curious. I mean, I understand that they fed the whole corpus of the repositories in GitHub to it, right? But I kind of doubt that there is a measurable percentage of those repositories that are actually using vectorized computation. So it doesn't really have much of the context about how to do it properly. Maybe that's something that we can fix eventually, but.
Yeah, train a model that does only SIMD, maybe.
All right, so one last question. Who is going to take one last question? Nothing? Come on. Okay.
Thanks,
then, yeah, thanks to Mikhail once again. Yeah, so let's have another short break. I think we have some food for thought and for the stomach as well. And yeah, see you again in 10 minutes. 1, 2, 1, 2. All right. Somewhere, like from the side. Would be, what do you guys think? Is it really something that is added as an additional layer, or do you think it's something that is more of a mindset? When designing something, it's you should be thinking about security from the start, and it's not like responsibility of someone else, but it is like everyone's responsibility of thinking about that. So, David, what do you think?
Okay, so it should be a culture shift, but I think, especially locally, no, it's something that's bolted on. Afterwards, I don't want to say it's laziness or anything like that, far from it. I think actually it's the opposite. Developers want to ship, and they want to ship fast, and nothing should, like you said, get in their way. Yeah? When things start changing a bit is when you realize that security and availability are quite intertwined. Like, you know, Java, I forgot the creator, but he said null was my $1 billion mistake. And, you know, like, it's the same for availability, it's the same for security. You know, how do you really know that no one is going to give a null in your, that leads to an SQL injection or this or that? When you start viewing it that way, you know, like actually paying attention to security might just save my ass one day or make my systems more stable. Then you start seeing this culture shift. You're like, okay, let me hit two birds with one metaphorical stone, you know? I don't know.
I agree with you, and I think it's also related to the maturity of the organization, in the sense that usually you would start, a company or an organization starts with small team, where the security would be a firewall and antivirus, and that's it. So minimal security controls, and you're okay. However, when the organization starts to grow, the culture starts to shift as well, and even the obligations start to shift as well. So that is where security would start being considered as part of the overall goals of the organization, because you will start seeing a shift to the governance aspect of security, the legal implications of not having security, and that is where I see a shift in the cultural mindset of an organization.
I remember back when we were kind of discussing what we were planning to discuss, you guys told me a couple of stories about new practices of like hiring people and doing like a security checks, right? Because I didn't really know that. I mean, I knew about corporate espionage, but I didn't know that it's like on a massive scale. So I remember you told me that there were something you did before, right?
So we had, if we're talking about war stories, local ones, when it comes to hiring, we, in Maltese, you know, like, although attend, be careful, because we hired someone, they went through this, it was a remote first position. We went through the interview, American accent, spoke very well, but, you know, passed all the background checks. And after a while, ping, ping, you know, suspicious stuff happening. Long story short, even though over the camera, you know, wave your hand over your face to see pixelations, that kind of stuff. After a long investigation with the police, it ended up that this guy was a North Korean hacker. And so when you think about it, you're like, a North Korean posing as an American and gets a job in a Maltese financial sector, and you're like, what is going on there? You know, like, but the reality is, we as Maltese start to get away with, I know we're small, who's going to look at us? We've seen stories about everything. You know, the small mama papa shops getting hijacked just for cryptocurrency. You have a Raspberry Pi that's unprotected, not patched in forever. Then you get a patch for your favorite IPTV program, and that's doing your cryptocurrency mining, you know, and everyone is getting, I don't know, 3 cents off everyone in this room, and over a year. You know, so even small actors, which we tend to consider ourselves, are fair game, let alone, let's say Altenar, 600 people, you're telling me, you know, access to I don't know how many bets and transactions, you know, then it becomes a real issue. Then you start seeing why North Korea, under so many sanctions, can't get proper mozzarella, you know, and they want, that's why they want, every little bit counts, you know.
I remember one of the ways of tackling that was, yeah, I don't know if we can tell that on stream, but yeah, it's like, there was a guy who actually written a post about one similar job interview that they had with someone who turned out to be a North Korean hacker, and they added a couple more questions to their interview, and one of them is something like, how fat is Kim Jong-un? And like, for North Korean guys, if they're actually North Korean, their first reaction is to just disconnect immediately, because, you know, nothing that they're doing is worth, like, what can come next. So,
to add to this, however, it's not just all of these bombastic stories that we hear about. For example, once I worked for a company where one day we noticed that a higher senior management official started deleting files from the server. And basically, he was on his way out of the company, and on his final days, he started deleting files from the file share, basically. And at that point, we had to decide, look, what are we going to do? He's still employed with the company. He's a higher senior management. Should we disconnect? What should we do? And thinking about it, this is someone who had worked for the company for, I don't know how many years. So we have to see it from both angles. The outsider threat, where someone would be trying to actually do us harm for some reason or another, maybe benefit, maybe, I don't know, competitive advantage, and even insider threats who, for a number of years, they're okay, they are people who we trust, but one fine day, they no longer have interest in the company and or the organization, and they just not tear in bed, but I don't know the exact word, but they might do something which is not normal. Yeah. I don't think it was something that was discarded. I think it was someone who was actually, for example, removing business contacts and this kind of activities.
So, and what do you guys think about iGaming specifically? Would you say, like in iGaming, I know there are a lot of regulations, different certifications that the companies should go through. Would you say information security is a bit different from the rest of like IT companies, for example, or what do you think?
One, for sure, an eye-opener for me. So a tiny bit of background is that I tend to deal a lot more with heavily regulated industries in finance, most of which have a smaller security team than you. But you know, the difference that I see in iGaming, for example, is that we had the presentation before. You guys have 2 minutes of downtime every 2 weeks. To me, that is such an insanely high bar, because even with banks, you're operating a SIEM, you know, something this or that. You can't afford a bit more downtime than that. You know, Swift happens daily, really. Forget Revolut and the others. These transactions happen daily. So, you know, you'll get hassled for 24 hours, and I said, here you have 2 minutes. Jesus, you know, I mean, for 2 minutes to me is, so that's one. The velocity of you guys far outstrips banking, government, you name it. I can't think of any other industry that moves that fast. So security needs to take that into account. No way you're going to put roadblocks to affect that kind of velocity, okay? That's number one. Number two is that you guys have, when you're talking about machine learning and this and that goes into cybersecurity, you always talk about baselines. Your baselines are different. A bank can very easily go and say, you know what, with all due respect to everyone, Russia, connections from Russia, no way. China, same thing. Africa, no way. It has to be Europe, because all our business, you guys, as we saw from the map before, you accept bets from anywhere, everywhere, all at one, you know, everywhere, anyone, all at one go. Totally different threat profile, right? So those kind of, between your velocity, between the threat profile, you're a different kettle of fish, which makes it more interesting. So at the end of the day.
I would say that we're the same and different at the same time, and I will explain why. For example, if we think about GDPR obligations, for example, we are the same as any other industry. So if you are holding data subjects information like player information and that kind of stuff, that is not different from the other industries. If you are operating, for example, a payment gateway, that is something that needs to be also regulated as the financial institutions. However, the difference that I see is the types of attacks that we are exposed to. Most of the gaming companies that I know are more affected by denial of service attacks, and that is something that even on paper it's very difficult to actually mitigate. You can buy DDoS protection and that kind of you can put in place those type of controls, but if they target you with a DDoS or with a denial of service attack, the only way to survive it is scale horizontally. Unless you scale horizontally, you're down.
So it kind of takes us back to the first talk, right? To scale everything horizontally, just in case. Also for terms of security. But you know, we are kind of supposed to be talking about SIEM systems, and I mean, to me, because I myself, I've worked for quite some time as an architect, as big data architect, and I'm kind of, we're building the platform, analytics platform here. To me, it was always interesting. What's the main difference between these things, right? Like, I mean, to me, most of analytics, the way it happens is, okay, we have like ClickHouse, or we have, you know, some data warehouse where we just stream the event data. And then if we want to find something, even if it's like some security analysis, we can go there and you know, run a SQL query and maybe find out something interesting, or do some projection via machine learning if we're fancy, right? But when last time I read about SIEM systems was that it is a completely separate thing where you're kind of supposed to be sending all the logs of all your applications and so on and so forth, which basically, from my side, from what I've seen, it does basically the same thing, right? It kind of tries to analyze, it just does it a bit differently. So, well, I mean, what's the difference there? What do you guys think?
So, yeah, so we're supposed to be building CyberSift. We are trying to build SIEMs and security solutions. I know there's a lot of data engineers, right, in the audience. Yeah, the last thing I was doing before I came here was dealing with missing fields in my JSON stream. I'm sure everyone here has data normalization problems, you name it. And at least from a in the weeds, low-level point of view, I honestly think that there is not much difference at all. If you have a solid, if you have a solid data ingestion pipeline, data curation, you actually are collecting the data in the first place. Grafana is a pretty good place to start. You're far ahead in terms of metrics and observability than anyone starting with just plugging in a SIEM over there. So our SIEM, a proprietary product, is very similar to an open source stack that you guys, Altenar, are using internally. We have a data store, OpenSearch. Why OpenSearch? It scales horizontally, ingests those of logs. Okay, there are little differences. Why not use MS SQL? It costs so much. OpenSearch is supposed to scale horizontally easily without much engineering effort. Could have been ClickHouse. Cloudflare uses ClickHouse. Yeah, so it could be any one of those things. What's missing between a SIEM and a mature, let's say, data-driven organization? An ETL pipeline, you need it in the SIEM. Literally before I came here, there was a LinkedIn post by some influencer who said, are you paying too much for Snowflake? Are you paying too much for Microsoft Sentinel? Then you need, I forgot what product, to filter out unnecessary logs. You can provide custom queries. And in my head, I'm going, that's ETL. That's your Python Airflow. That's your Niffy. That's your whatever it is. You're just packaging these ETL pipelines into a security spin. But essentially, they are the same. Where does it really differ? Your queries. We are looking for one thing, and marketing is looking for a completely different thing. Sometimes, because sometimes, again, real stories. Security alerts were under a DDoS, and then everyone kicks in. We call Go, our telecoms provider, and then after we took all the corrective measures, marketing calls us. We had a campaign that went viral, and you effers blocked everything. You're like, oh. So the DDoS was actually a viral marketing campaign. So even then, the queries are kind of related, but when it comes down to it, it's the queries, it's your detection, it's your automation around that. That's the major difference between a data-driven platform and the SIEM. But to me, other than that, they are the same.
In my opinion, they are the same. Again, just looking at different things and making sure that you are ingesting the proper data. That's the main difference. That is, you need to make sure that you are monitoring the correct logs. Again, as David said, you need to make sure that the data is there and then process the data to be able to actually get something valuable from it.
But does it also mean that, like, let's say logs should be structurized, everything should be like, I don't know, presented in such a way which is acceptable to send to the system, or it can be just like a stream of text, I don't know.
A stream of text, but the difficulty then is to analyze the data, in the sense that usually imagine where you would have unstructured data. What are you going to look at? In the sense that you can do queries, but the queries would be generic and the performance will not be good, similar to what Irina was
I
saying.
think that's part of the reasoning for using OpenSearch, right? Like, because it does full text indexing and like in the worst case.
And in fact, some of the work that needs to be done with OpenSearch, for example, is that you would need to not filter, segregate or parse the logs prior to going into OpenSearch so that you can have the correct fields and the correct types. I remember some work that I had done with David, where, for example, an IP, if you don't define it in the correct way, you wouldn't be able to query it using, for example, the subnet mask. You would need to be specific on the particular IP. So all this work is important to actually be able to work on the logs that are received, and you would be able to do something about them.
Then once the security team has to go through all this work, and I think fair to say 33% of my time would be spent as a developer normalizing fields. So we went through all this work, but then your marketing department goes, I don't have any data about what visitors on my site I have, when in reality security are doing this. It's like all you need to do is probably spin up a dashboard, like we were saying, a different view on the same data, but these guys did the hard work for you, It doesn't have to be Google Analytics. It could be this kind of data, which is interesting for cross teams. I think once people start realizing that, security is doing a lot of the work for their ends, but I can piggyback on it, then it's great. We can take some learnings from the database girl over there. I'm taking back because I have the same issues, right? We use Postgres with contention. So you're like, it's like, actually, in this case, database girl did the hard work for security, but it could have been the other way around, right? So that to me is what really then sparks this synergy and makes a company more secure, kind of by accident, because everyone's working together.
Yeah, that's kind of part of me, though, immediately thinking of ClickHouse there, because it is kind of right optimized. It seems from my perspective, it seems like one of the choices that could be done there, but it needs to utilize it properly. It needs also the data to be structured. Right, and that's kind of the tricky part. I mean, you can't write JSONs probably.
Exactly. I think very recently with Postgres, for example, going down JSON-B, the JSON-B route, and ClickHouse also doing that, and big names like we just mentioned, Cloudflare, releasing blog posts and how they use it. Then you start going like, actually, guys, we can start off. Like Keith said, there's a lot of work that we have to do for normalization because it gives us security. And that will take us, 60, 70% of the way. Then we'll get the rest of the unstructured data on our JSON-B columns. If we start seeing a lot of hitting there, and that's where you need observability, rope in your data teams, who is hitting what columns, then maybe we should normalize that particular part just to get those extra performance benefits. But yeah, 100%. They are. It's no longer clear-cut between NoSQL and SQL. Now it's like a weird mesh between them. Yes, NoSQL, something.
This is something that I am usually faced with. So should you give the security tools to other departments? And that is a question that, or a dilemma that we are usually faced with. Obviously, everyone would have, in my opinion, his opinion. And usually I don't agree personally that you should give the security tools to people outside of the security team. And one of the reasons is basically segregation of duties. And there might be sensitive data which might not be exposed to other teams. So this is always a dilemma. Should you give access to, for example, the SIEM, to external parties outside of the of the security team? I don't know you, David.
This is a question where I'm a bit biased because I agree with you in the sense that from a pure, if I were working in your position, I would back you up 100% there. You know, then before we even go down into performance and this and that. But at the end of the day, then when I put like, not necessarily a selling hat on, but as a manager, you know, who of you really wants to spend money on insurance, you know? And that's how most people view insurance. You only buy insurance once you crash the car or your wife did, whatever. And then you need it after the fact. But that's the wrong, you can't sell products that way. But even as a manager, you can't really sell how important security is after the fact. And one way of really pushing it home is like when we speak about ROI, return on investment. Then giving access, you know, the same work, but many people benefit, all of a sudden your ROI discussions change. And when you view it and then from that lens, you're like, okay, maybe it is worth having, and there's a lot of work, making it multi-tenant. The data team has to access this. Then does my database support document, if we're talking about OpenSearch, it does. Does it support document level security, or can I only can I have to share the whole table? Can someone have? It's a mess. But then when you look at it from ROI, if you are in constrained budget environments, then it becomes a very good something worth considering. It will make it easier to introduce security from the back door, kind of thing, you know, as a higher ROI. If that were out of the picture, 100%, then it becomes, the risk-reward becomes unbalanced. It's probably not that great for your front-end devs to be able to see transaction data going around, you know, with ID cards and PII. Also because you don't want your front-end dev to be somehow culpable, you know, which in security you are. Like, you splash damage, you know, the police investigate something and you're on the line because you're a witness.
I know that you're definitely biased here, but I want to ask, do you still think it's feasible to, let's say, build your own internal system as a SIEM instead of like going to vendor and paying them?
Whenever we're trying to sell our product, this is the same question we get faced with. And the answer is you can build it, you can maintain it probably, but the operation, and this is something I'm being very candid, we struggle as well with it. Like when you're operating a SIEM, so we were talking about queries before, who is going to come up with these specialized queries, you know? And like, so when you think about it, let's break it down. I want to catch, I don't want to be hacked. Okay? Now, I don't want to be hacked means a lot of things. It's like, should I look for an insider who all of a sudden changed their behavior? So, and then you're saying, I need to forecast predictable behavior, and then if it changes, alert. Do I want to catch that external state actor? Who is even targeting me? I need someone to keep an eye on the news. Then I need someone who knows what they're doing. Most of the time, this excludes me. And they're talking about PE headers and assembly, and maybe you would know. You're like, is this SIM the command, or is this an obfuscated web shell written in? And you have to write a query that somehow marries the data you are collecting to pointing that out. That is the hard bit, right? And here, as a small local company, I have to say we piggyback a lot on open source, where our main job is probably not coming up with these queries directly. As a small company, like or a small team, or if you're building it yourself, I would say it's almost impossible. Most of the work goes, like Keith is saying, how do you translate those queries to match the data that you are collecting? If you're not collecting the data, then you have like, is it a risk? Do I need to collect that data? Will it benefit anyone else? Because that changes the dynamics again. So it is feasible to build, for sure. I can give you a whole list of open source technologies that our SIEM itself is based on. But then operating it is a whole different kettle of fish. And there you're probably not as easy doing it on your own. You would need some external help, open source, big guys, whatever it is. Right?
I've done both.
Yeah, it's done both.
So what I can say is that there are advantages of buying the solution, and as David said, one of them is usually companies who are specialized in this kind of software would have data coming in from different sources. So they are seeing data from different sources, and basically you are benefiting as well with any improvements to the system that they are doing based on other companies. So that is one of the main advantages that I see. Usually the teams in Malta are very small, and spending time to keep everything up to date, it's quite a nightmare, I would say. Now, doing it yourself will give you flexibility. Flexibility in the sense that no one knows your environment better than you. So knowing what to look for in your data is something that only you know. So basically, if you had to set up the SIEM system yourself and then tweak your rules based on your environment, that is the ideal solution. If I had to buy a system, an outsourced system, what I would look for would be the flexibility of the system, how much flexibility does the system gives me, and even a good partner, in the sense that if the partner is quite rigid in what he's offering, obviously that would be a no-go.
Thank you. So I have one last question, I think, before maybe there will be some from the audience. Just to go back a bit to to different stories. I'm just curious. Like, I know that there are a lot of attacks happening on the internet, like by the bots. There are scans, so on and so forth. I think my question is, what's happening more frequently? Like, someone actually attacking and trying to breach the internal network, for example, and steal some data, for example, or someone from the inside making, let's say, an honest mistake and copying over some like private data to their own machine, or offload it to some public cloud, which is not allowed, and stuff like that. What do you think?
It's a toughie, because the latter scenario, when it's really an honest mistake, we typically don't tend to consider it as an attack. Exactly. Honest, yeah. But what I can say recently, for example, is there's that joke like, listen, I don't need to swim faster than the shark. I just need to swim faster than you. Yeah. That's what it is in security right now. So I don't know Altenar, but you most definitely have some third party who are vulnerable. And they happen to be small, and they happen to have a hole, and they get hacked, and from there they get to you. Or you're heavily using open source, and from who said this? When we're installing NPM, there is a list longer than my arm, yeah. And one of those is compromised. This is your supply chain attack, that has become common. I mean, MNS, these recent cybersecurity attacks were all hacked through a supplier, stolen credentials of a supplier. But still, so is the supply chain. Log4j was the genesis. That has increased a lot. SolarWinds, that was a biggie. Microsoft, for example, not to badmouth them, Microsoft still have had suspicions that Azure has been hacked by Chinese state actors, and they haven't yet proved that they are not still in there. And the way that happens is because they suspect that they hijacked federated authentication, you know, how the way one system trusts another, so instead of having to sign in 8 times, I sign in once. And when we think about it, that's another spin on the supply chain, right? So I trust you, but you are vulnerable and you get hacked, so, you know, contagion. That has become a real issue, and that's really difficult. How are you going to, we were talking about this with the security team before, you essentially now have to audit not just yourself, and now with DORA and all these, not just yourself, not just your first-line suppliers, some auditors are asking for third-line suppliers. So that has become a headache, and it's going to be, with AI, worse. You know, it's going to explode. If you had to ask me what's really going up there, it used to be ransomware, it's still there, but the supply chain is slowly becoming more and more prevalent.
Your question is difficult to answer, and I'll explain why. Usually when someone tries to attack you from the outside, he would be limited by what you would have exposed. However, when someone does a mistake from the inside, most probably you would have trusted him in the first place. So if you have someone from the inside who intentionally or unintentionally tries to do something, most probably initially he would have much more access than someone from the outside. So the blast radius, I think, would be much faster if there is an internal employee, for example, which has done something malicious or by mistake.
And how do you detect it? Right? I mean, if you have someone on the inside, it is like, you know, on the outside, you might see there are clear signals. On the inside, you know, you gave this guy the key, so you're not seeing any scratches or any forced entry.
This is something that we talk about continuously.
Oh, yeah,
How are we going to detect, for example, if someone had his password compromised? How are we going to detect it in the SIEM? Unless you have some behavioral analytics where he would try, for example, to access something that he usually doesn't access. But if you don't have these kind of tools and technologies in the background, it would be a genuine log entry in the SIEM, which it's okay, nothing wrong, let's move on with the day.
Even then you end up in a machine learning nightmare. False positive rate, false negative rate, and you're like, oh God, I'm getting too many alerts. We've had a lot of conversations about this, but you know, at what point does the dial flip to like, you know what, this guy is really doing something bad? That is an insanely difficult decision to do without your security team just drowning in so many alerts because I decide I have the Champions League coming up and I needed to log in on the weekend. You know, that's a very difficult call to make.
Thank you. Yeah, so I'm afraid we have to wrap up. This was a really, really amazing discussion. Thank you, guys. So I'm ready to give up my microphone because I'm definitely the most ignorant person here on stage. To some of you guys, you have a unique opportunity to ask security experts about some things. Maybe you had some ideas. Yeah.
All right, I get a first question. So, a context. I'm a software architect who ended up doing the security in a small startup. What should I focus on beyond the usual software engineering stuff, like decreasing amount of permissions everything has and removing as many dependencies as we can? Anything that is specifically security that is not what I had done before as a software architect?
I am biased, but there's always two, but I'll split one off. There's always prevention, so you know you need to have a good EDR. Yeah, these are all the normal things you need to patch. And now this is why I tell you I'm a bit biased. But to me, observability or detection plays a big role because say something happened, and this is something we're dealing with now with a recent customer. Something happened, and they come to you and they're like, what can we do? Like, you're really not helping us. You know, CyberSift, you're really not helping. You're like, but guys, you got hacked, so you're dead. You have no logs, you have no activity logs, so you're not even giving me a body to do an autopsy on. So you can spend all the money you want on these fancy tools and call in Microsoft but if you don't know, if you can't build that kill chain, you're busy locking the door when the window is wide open. And I understand why that is hesitant for people to address, because there's storage costs. You need to build a data pipeline. You're not going to have any problem with this based on your talk. But, you know, for the average Joe, that is something that I think is overlooked. And then there's the problem, like, I don't know what I don't know. It happens to me a lot. You're using what? Oracle Cloud. I never ingested stuff from Oracle Cloud. I didn't even know you could, you know. So I understand it's difficult, but it's important. The third, which really the other two depend on, is what we were talking about before. It's people and processes. The amount of times, as a CTO, I would be like, guys, the alerts are right there. But, you know, we're tired. There maybe LLMs can help. We're seeing, I really am seeing kind of a helping hand over there. Not to replace the guys, but literally because you are dealing with 1,000 alerts per second sometimes. It's insane. So having a good playbooks, you know, you're on call, shit hits the fan, you're not thinking straight, the dog just shat on the floor, you don't know what's going on, you don't know who to contact, that's another thing. Who takes care of the system? But unplug it. It was our main web server, you know, so that bit is the technology you can solve. The people part, you're gonna suffer.
What I would add to this is know your perimeter. Know your perimeter in this sense. Know what is exposed to the internet. And if I had to start from somewhere, I would start from there. Having said that as well, the perimeter is changing today, in the sense that before everything was in the data center. Today, everything, you might have a service in the cloud, your user's PC, which is not protected properly. So working from home. So I would start first by looking at those avenues of attack, and then obviously move always inwards to see what additional measures you can put in place to protect yourself.
Thanks, guys. Fantastic talk. Actually, 3 talks. A great event. So my question is to Keith first, and then another question to David, if that's okay. So Keith, as a security professional, the one thing that's very relevant, and it's been touched upon in the beginning of the talk in this philosophical part of whether security is a bolt-on or the core of the development effort, right? And the way that typically translates in the cybersecurity industry is, do we shift left security to DevSecOps, or do we do it right? And then, you know, the tooling can be different for both. In your view, how left do we go? Like, what is the best way? Where do we start with a DevSecOps effort? Or maybe in your view, we should actually go right with security?
I would say you should start before. And what I'm saying start before, it means that, so when you're talking about DevSecOps, you would already have started building something. So you would need to start before at the design stage. So basically one practice that we do here at Altenar is that products that are going out on the market, before they are actually, we start implementing them, the teams obviously involve us to understand the risks, the security that we should put in place in building up that product. And we would have discussions on how to best create a product from with security built in. And then obviously, as you said, you start shifting right. We have tools which go into the pipeline, where we do SAST, we do DAST, and then once a product goes into production, obviously you would need to, with every change, and on a regular basis, confirm that the product is actually meeting the expectations from a security angle as well. So it's not just moving left, but from start till you decide to throw away the product.
Gift for cybersecurity vendors, by the way. David, so you mentioned a very important thing. You kind of compared the cybersecurity to insurance a little bit in that you don't know why you want to pay for it until things happen. So how do you, in your capacity, typically position the metrics for ROI? Like, how do you actually get your customers to say, yes, I can measure success of my purchase?
Ooh. You know, I think it's no accident that most of our customers are heavily regulated, because that is what your question is so difficult to answer, that most of the time it's because the policeman comes, the longer arm of the law, and says, no, you have to have it. And kind of like it's forced on you. But that's why, and then I always kind of, there were discussions like, how do you increase the ROI? Because if it's been forced on you, you might as well use it, right? Internally, when we operate a SOC, it's a bit of a different story, because how do you measure someone's performance when ideally they don't catch anything? Ideally, you're so secure that there is nothing to find. So then your metrics for success have to be different. They're like not how many lines of code, test coverage, this or that. Then internally, we're talking more along lines of, listen, what efforts are you, how much effort did you successfully put in to reduce your false positive rate, okay? Or conversely, how successful were you in modifying whatever rule it was to fit a particular customer's or your own environment, because every environment is different, right? Like we were saying, if you guys have connections to Russia, it's one thing. If a bank in Malta does, it's probably a different story. So that's how we really measure success. Like, listen, remember how before, once you were introducing the product, you were getting so many crashes or you were hitting bottlenecks so far, and then you introduce security, and as a byproduct, those finished. You're also more secure. That is a big return on investment for almost all our customers. That's why I said, like, sharing the data when you're talking about ROI is a big spin. Unfortunately, just like in insurance, no one thanks you, well, in all IT, sysadmins as well represent. No one thanks you for keeping the servers on, right? Everyone blames you when they're off. So there is that, 100%.
So remember, like, one question that sparks really interesting discussions, usually inside the company, talking about something like that, like if we are deciding about the level of security to put on some data set, for example, some database, it usually works wonders if you come to top management and ask the question, what would our competitors do if they had this data? And it usually starts,
So, and then assessing, like Keith was saying, kind of, don't just take the perimeters. What are your crown jewels? What's the reputation? We were talking, how do you put a price on an intangible asset, or like reputation and risk, you know? Is it priceless? Everyone says it's priceless, but there's probably a price to it, right? So start from there. What's the worst that can happen? Put a price tag. How likely is it to happen? That's a different price tag. That's probably where your expenditure would be, you know?
Thank you. So I think we have time for one more question, and I guess we'll switch over to.
Thank you very much, guys. An amazing talk. I was wondering about what you do when you're in a startup, and let's say you're you and maybe your buddy working with you. How you go about security there? Then, are there any cookbook maybe how you can protect your future project which you're working on, or like any suggestions on that?
So if it's you and your buddy, you don't have to worry that much about traditional infrastructure problems. It's your laptop, another one, the cloud. Let's say, probably if it's you and your buddy, you're heavily, at least initially, in the cloud. Am I right? If it's up to, let's say that. there you're at a bit of an advantage because the big players, it cuts both ways. The big players are going to inherently have sane defaults. They're also a bigger target, like we were saying. Depending on what you are doing, so when I started out with CyberSift, our tech stack was Go, actually, and Kotlin. And their tools are your best friend, right? Because security isn't your main focus. And you have to be brutal in your triaging. Like where banks and iGaming have this risk appetite, your risk appetite is a lot larger. And let's be brutally honest, as a startup, you have a lot to lose, but not that much. Right? It's more important for you to get your product out there, buggy, whatever it is, see what the market feedback is like, then tweak it down. But if you are looking at specific languages, there are plenty of really good resources out there. OWASP is great. The more established your language is, like Java has been around for dog years, and there's OWASP has step by step what you should be looking at. If you look it up online, there are guides, for each and every one. That helps to shift left, and it will help you in the long run. How much time you spend on it is a very personal decision. I personally like run fast, break things, and now we're a certain size. I can't do that anymore. But initially, it was more like, listen, yes, let's make sure that we don't have data leaks. Let's make sure that me and my buddy, it's very easy, decide to use one service and one service only, not 5 different things. And then all of a sudden, damn, I forgot to reset that password, that link, it's an operational thing. That's what I would tell you to do, like build around that.
Yeah, thank you so much. I hope it was like really, really interesting for you guys as it was for me. I definitely learned a couple of things. So that was the last session for today. And that was another Malta Tech Talks for you guys, and hope to see you on other events as well. I mean, it's maybe for some of you it's just getting started because we still have some food, some beer, and everything there. I mean, yeah, knock yourself off if you want to discuss something, if you want to catch these wonderful gentlemen and ask them more questions while they're still here, please go ahead. But I think that concludes the official part, and yeah, and see you all again. Thank you.